Hi class, in this video I am going to show you how to work through some word problems from section 6.5. The first question says an object is dropped from a weather balloon 1,600 feet above the ground. The height h in feet of the object is modeled by the position equation h equals negative 16 t squared plus 1,600. Where t is the time measured in seconds. How long will it take for the object to reach the ground? You probably read through that and think, what is it talking about? It is just talking about solving the equation for t. How long will it take the object to hit the ground? And we have just spent this entire unit factoring, so we will continue to factor while solving this word problem. So we have the equation right here in the middle, h equals negative 16 t squared plus 1,600. It's asking us to find t, but we can't find t without first figuring out what the value of h will be. And we know h is the height of the object. We can say h is 0 because it is 0 feet from the ground. And so all I'm going to do is rewrite this equation, negative 16 t squared plus 1,600 equals 0. And hopefully you recognize the format because we just solved some zero factoring equations that look just like this in this section. The first thing I want to do is factor out a negative 16. The reason it's a negative 16 is because the leading coefficient is negative. And so that's always a clue that your greatest common factor will also be negative. That leaves t squared minus 100 equals 0. We can actually ignore that negative 16 and just focus on factoring t squared minus 100 and set those factors equal to 0. This is a difference of squares, so it's t minus 10 times t plus 10. That equals 0. According to the zero factor property, either t minus 10 has a value of 0 or t plus 10 has a value of 0. This first one over here on the left, t equals 10. The second one will subtract t from both sides, and t equals negative 10. So we have two answers, which is totally normal. We've had two answers on previous problems, but because we're working with an application problem, one of the answers will make sense and one of them just will not make sense. Go back to this original equation, it's the last sentence. How long will it take the object to reach the ground? And then go back and look at the different values for t. Will the object take 10 seconds to hit the ground or negative 10 seconds to hit the ground? Well, the negative 10 seconds does not make sense at all, so we'll throw that answer out and we'll stick with the answer t equals 10 seconds. This one says a diver jumps from a diving board that is 32 feet above the water with an initial velocity of 16 feet per second. The height in feet of the diver is modeled by the position equation h equals negative 16 t squared plus 16t plus 32, where t is the time measured in seconds. And here's the question: how long will it take the diver to reach the water? So again, in this problem we're going to solve for t, but we first need to come up with a value of h. And if you look right here in the picture, it gives us that the height is 0 feet because that's when the diver hits the water. So now I'm going to take this equation given in the word problem and rewrite it. Negative 16t squared plus 16t plus 32 equals 0. The first thing I'll do is factor out the negative 16. Again, the reason I'm factoring a negative 16 out is because the leading coefficient is negative. And so that's the clue that my greatest common factor also needs to be negative. I'm left with t squared minus t minus 2 equals 0. You can ignore the negative 16, which is the greatest common factor, and let's just focus on the trinomial t squared minus t minus 2. Factor that trinomial. That'll be t minus 2 and t plus 1 equals 0. And again, the zero factor property says either t minus 2 equals 0 or t plus 1 equals 0. On the left side, we'll add 2 to both sides. T equals 2. On the right side, we'll subtract 1 from both sides, and T equals -1. How long will it take the diver to reach the water? And we know T is in seconds. Does it make sense for our answer to be 2 seconds or -1 seconds? Well, again, we can't have time in negative, so we're going to cross out our negative answer, and we're going to stick with T equals 2 seconds. The length of a rectangular painting is 3 inches greater than its width. The area of the painting is 108 inches. Find the dimensions of the painting. So first of all, as a quick review, the area of a rectangle is length times width, and the picture has already given us the width and the length, and so we'll say x times x plus 3 equals 108. Let's go ahead and multiply this together using the distributive property. That would be x squared plus 3x equals 108. Are using the zero factor property, go ahead and subtract the 108 over to the left side. X squared plus 3x minus 108 equals 0. Now we'll factor this. It will be x plus 12 times x minus 9 equals 0. Now set each of these factors equal to 0 and solve for x. We'll subtract 12. X equals -12. Over here to the right, we'll add 9, and x equals 9. So we're left with 2 answers, but because this is an application problem, one of the answers will not make sense, and that's our negative answer, because the side of a painting cannot be negative inches long. So we'll stick with the x equals 9. So we know that it's 9 inches on the width, and we know the length is 9 plus 3, which is 12. The question says find the dimensions of the painting, and we can say this is a 9-inch by 12-inch painting. The length of a rectangular poster is 2 times its width. The area of the poster is 648 square inches. Find the dimensions of the poster. We're going to follow the same procedure. Area is length times width. And so this problem we have x times 2x equals 648. Go ahead and multiply that together to get 2x squared equals 648. Because we're still using the zero factor property, let's move everything over to the left side. 2x squared minus 648 equals 0. Factor out the greatest common factor of 2. That's x squared minus 324 equals 0. We can ignore that 2 and just focus on this difference of squares, x squared minus 324. And if you're not familiar with the square root of 324, just quickly take out your calculator to find that the square root of 324 is 18. So this will factor to x minus 18, x plus 18, and then we'll set both of those equal to 0. And do you see that we will have an x equals positive 18 answer and an x equals negative 18 answer? Because we're talking about the dimensions of a poster, we're going to throw out the negative 18 and we're going to keep the positive 18. And so now we know x is 18 inches, and then 2 times 18 is 36 inches. And so the dimensions of this poster is 18 by 36 inches. The width of a rectangular garden is 4 feet less than its length. The area of the garden is 320 square feet. Find the dimensions of the garden. This question is actually the same, it just did not offer a picture, but I wanted to put it on this video to show you that you can draw a picture and you can figure out this problem by just looking at what the word problem says. So we have a length, and we know that the width, which we'll call this the width, is L minus 4 because it says 4 feet less than its length. And so to write that phrase out, it's L minus 4, and we know it multiplies to 320. So here's the equation we can make. We have L times L minus 4 equals 320. Use the distributive property to multiply L squared minus 4L equals 320. Move everything to the left, so subtract 320. Now we have the trinomial L squared minus 4L minus 320, and we're going to set that equal to 0. There is not a common factor, so we can go ahead and just factor this problem. We'll put an L in the first position, and now we're looking for two numbers that multiply to negative 320 and add to negative 4, negative 20 and positive 16. Those two numbers multiply to negative 320 and add to negative 4. Now set both of those factors equal to 0. On the left side, add 20 to both sides. L equals 20. On the left side, subtract 16. L equals negative 16. We will throw out the negative answer because it does not make sense with our word problem. And we will keep L equals 20 feet. And that means our width is 20 minus 4, which is 16 feet. And so the dimensions of this garden are 16 feet by 20 feet. And that's all the examples I'm going to do on this video. Please let me know if you have any questions.